What was the biggest challenge for you this time?
Getting the comparator right.
Comparator, yeah. So, good morning. We are the guys from Germany. We are Frank. Good morning, Frank.
Hello, Thomas.
We are Achim. Hello, Achim. Good morning.
Hello, Thomas. Hello, Frank.
And
Hello,
it's,
Achim.
and it's me, Thomas. So, we waiting for the start. So, 5 seconds left. 4, 3, 2, 1, go.
There's some signal, you who...
Distress signal.
It sounds like Dijkstra. Distress, Dijkstra. Is this a hint? How to solve?
The pairs of packets. The one line is one packet, yes?
Seems so.
And they called left and right because it's the top and the down. It's otherwise somehow. Packet data consists of a list and integers. Of lists and integers. Okay, everything between brackets is a list. Like this. It is always a list and appears on its own line. Okay.
So, sorry, Frank. There's a hint because I'm recording the session. Sorry. Can you click on it?
I don't see any hint.
Oh, sorry. What was on my screen? Sorry for interrupting you.
Okay. So it's again more kind of simulation today because we need to implement these rules correctly and then it will work. So on the other hand, the rules are not that simple like it was the days before. Kind of recursion here with the lists. And also we need to find a nice way to build this parser.
And you have to count the pairs of the right order.
Yeah, okay. Then you get an input, you get a lot of pairs, and you need to count how many are in the right order and how many are in the wrong order. So basically you implement a comparator for these kind of lists. So first thing is we need to decide how to use, what kind of data structure to use to implement these lists. So I'm thinking about linked lists. So we can build something like a tree structure here. So.
And what about the sorted linked list, or it doesn't matter?
Now the point is that that elements in this list can be integers or other lists. So this is the more important thing. So
Okay.
Of course it must be sorted. So, but yeah. Yeah, I will use a simple array, and if it's values, I use negative values, and if it's positive values, it's a pointer to the next list. So I guess this will be the simplest form.
Okay. I will follow you.
So what about the length of the list? The length of the list is... No, it's not good. A list of integers.
Or in the real data is very long.
Yeah, of course.
Yeah.
So first I will remove all commata. This will make parsing simpler, I guess.
The comma is an valid input. Is it a... Well, maybe I'm wrong.
What's your question?
Yeah, one moment. I missed the line. Contains 0 or more comma-separated values, either
Yeah.
integers or lists.
Yeah.
Sorry, maybe I was wrong. Sorry to interrupt. Each packet is always a list. Okay, it's always a list. Okay.
Yeah. So each package always starts with an open bracket. It's like this.
Mm-hmm. So every open bracket is a new list.
Yeah, that's also true.
Okay.
So just put them on a stack or what? So now I'm making a function here for parsing one of these lines with these brackets and so on, and bring them in a form where I can compare them afterwards.
Yeah. Have you recognized if there's only one value, convert the integer to a list, and then retry the comparison?
The comparison follows these rules that are explained here in this block.
Okay.
So, but now I'm at a parser. First, I need to parse this thing. Oh, I do it otherwise. Come on. So now I changed my plan. I don't use an array to store this data. I define kind of a node which can then be linked to parent and children.
Okay.
But I usually don't do this. I need to work with pointers here, which I barely never do. So actually, the simple data structure is too much for me. I never did things like this. To think about it. Is this the tokens?
So I need 50 minutes to completely understand the riddle. Interesting.
And then you implement it, and then you retry again and need the next 50 minutes to really, really understand it.
Yeah.
So now I'm inserting several spaces into this string that I can simply parse it. So something is here wrong with my code, because my auto formatting does not work correctly. This means I got some wrong here. So this is something which does not work very good for me, this riddle.
No?
This data structure is, I'm running out of ideas to find a good solution, so this will be pain to implement. And I know it right now. So having difficulties to implement a parser is not a good sign.
Why not?
What, why not? Why not what?
You said parser is not a good.
Having difficulties to implement a parser is really not a good sign. Implementing the parser should be like nothing. So
yeah,
if I need more than 2 minutes to implement a parser, then I know it's not a good day for me.
Okay. Okay.
And I'm working now 15 minutes on it, and I still don't know how to tackle this. And this means I probably won't solve it at all or something like this. I'm overwhelmed by this data structure. And while thinking about this problem all the time, I'm barely able to write down the simple code. Here you see I got some braces wrong, and I don't see why or how. Well, okay. Now it's compilable at least. But it more or less does nothing.
Some success on your side?
Well, my parser seems to work now. Now I will check if my data structures are created correctly, and then I will start to implement this comparator.
Yeah, okay.
So kind of in the first step of 3. I'm trying to output my first, from these pairs of lines, always the first one in a parsed form to see if it looks correct. So this thing is actually this line here. At least it should be. So it starts with an value 1, okay. No, starts with a list 1, which is okay. And then this list 1 starts with a value 1, which is okay. And then the next element is the second list, okay. And this starts with the value 2 and so on. And then at some point the 5, 6, 7 comes and the innermost list. So this looks not. So let's look another example. This second here, because there's 2 lists within 1 list. So this would be where is it? 1, 2, 3, 4, 5. Should be somewhere here. Here it is. Oops. Here it is. This is a list of 2 lists. So this is list 1, this is list 2, okay, and the list 1 is made of a -1. And then there's this third list. This is not good. This 3 is wrong here. And this 2, 3, 4 is okay again. So this 3 should actually be after that 2 here. Because the first list, the outermost, has 2 elements, which are 2 lists. So, and we got this here. So why is this?
Okay.
So whenever I find an open bracket, I push the current element, which is this IDX, to the current topmost list of the stack.
But in this case, you got 2 open brackets together. Is it handled by you?
Yeah, of course. This is the first level list gets started with the first bracket, and the second list gets started with the second bracket, and the 1 is put onto the second list. Then the second list is finished, so it's popped from the stack here. So then there's a new open bracket, which is the third list, which starts with 2, 3, 4. And then the third list finishes. And the point is where the third list starts, the topmost on the stack is the first list, not the second, because the second was popped from the stack here.
Okay.
And then when the third open bracket comes, this IDX of the third list, which is a 3 also, should be put onto the first list, but it's put somehow on the second list for some reason. And I don't get it why. So I need to rethink what I'm doing here. Minus I other values. Let's look again at the example. Oops. So here, first list. It's a 1, which is okay. Second list. Oh, nope. That's something not correct. So I'm starting with a 0. 0 index is a... Okay, maybe I should simply remove the first open bracket, because I always know it's the first thing. Yeah, okay, I will do that. Maybe that's better.
So you hard remove the first bracket, and what about the last bracket? Doesn't matter, the last one?
Yeah, I initialize this whole thing while pushing a 0 onto the stack, so the last bracket will pop the 0 from the stack. Not sure, but maybe it works better. Let's give it a try. So we are in trial and error mode anyway.
I understand.
So like this monkey is trying to type Shakespeare's Hamlet. So look at this beauties. There's a 1 and a -1 and a 2. And it's wrong.
Is it possible that you miss the first group?
Not sure what you mean.
Okay.
Think about how you phrase it.
In your output, you're starting with double S. Not in your code, in the output. And
Okay.
it seems like that you only output one group.
Yeah, I'm parsing one line after the other. So
Yeah.
this is one thing I'm parsing, one line. Yeah?
Yeah.
And this is exactly my line when after I pre-process this. Pre-processing is removing all commata and inserting some spaces. So I can split this by white space into token. So these numbers are one token and braces are one token.
Okay.
So, but otherwise it is the same as before. So you see this here like this. It's a 1 and a 2, 3, 4, and it's a 1 and a 2, 3, 4, and it's the same. So now what I'm doing is when I find an open bracket, I create an index for a new list, because whenever there's an open bracket, this is a new list.
Yeah, okay, I understand.
So, and then I look what is inside the list. If I find a number, I put this number into my new list.
Okay,
and if I find another open bracket, then I create once again a new list and put the index of this new list into the old list.
Okay.
So, and then I push this new list onto the stack. And so when there's a closed bracket, I pop it from the stack. So always the topmost element on the stack is the index of the last open bracket.
Okay,
and,
then I do not understand the second line. You marked from your marked line. You marked the list with 1, and the second group is 2, 3, 4. Yes, and then one deeper, one down, you got 1. This means you got the first group, right?
This means that in the surrounding list, which starts here at index 0, first element is a 1, and it's a 1 because the second list gets as index a 1, because there is a positive 1. And then in the second list, which has the next index, here this value 1
you got 2 groups
as a -1, because the values I enter as negative values. So, but then the second list should be finished and the third list should be done with 2, 3, 4. And this index of the third list, which is here a 2, should occur here after that one. So this should be 1 and 2. And then there are -1 and -2, 3, 4. So this 2 is in the wrong row.
Okay.
I don't understand why. It has obviously to do with my stack handling, because there is where I decide where to put this value.
Okay.
So now I show it in the code. If I have an open bracket, I create a new index as my current size of list. So I create a new size. I push this onto my data thing, an empty array for the new list. Maybe I can move it here. So then I stack.top is always the index of the current list. I push back this index, and then I push this index onto the stack. So there's always this new list on the stack. I still don't get it. Why this does not work. It's no fun.
No. much time to pass the input.
Yeah. And just outputting it now once without this leading thing, but this is okay. Looks okay for me. This is like it should be. But let's look some other example. Maybe then I see more in it. So this 2 is somehow wrong here. So with the 9, simple list with the 9 is okay. And this with this 4s. So first is a 1. And the 1 has 4 4s. This is also wrong. But for some reason, there's a space missing here. Okay. So you see that? I substituted everything so each token is surrounded by spaces, but the closing things are not. So now I changed this and now it might work better. Yeah. So it misses some closing brackets. Maybe all. So now you see this here. 1 and 2 are in the first list and -1. This is exactly what I wanted. So now I can implement the comparator. So 40 minutes for the parser, which I guess the first to solve the whole riddle, we do it in 4 minutes. So 10 times the whole riddle is for the parser for me. Not nice. But this was all debug output here, wasn't it? I did it like this. So now how to compare these things? If both values integer, compare the integers. Okay. So if it's a value and A2, E2 is a value, then return 1, E1 kleiner a, but only if they are not equal. A1, E1 not equal A2, E2, then return this. Else jump into the list. So let's do it like this, while true. So this would mean it's equal. Right. So I need to use stacks here, isn't it? Yeah. Stack. Yeah. Yeah. Complicated data structures here.
Yeah. So I'm back in a minute, but I wrote my parser in a very easy way. Interesting.
Nice.
Cool. Back in a minute.
Okay. We need to do this recursive. That's it. No stack. So this recursive definition of comparison in this list is For me, it's super clumsy to implement, super complicated to wrap my head around it.
I understand exactly what you mean. For me, this is the same. I got a list of integers.
Yeah. Yeah, well, me too. Two-dimensional array of integers.
I'm sorry, my micro was muted. I have succeeded on part 1 and I'm now going onwards to part 2.
Great.
Congratulations! Congratulations, Achim.
I had a serious bug in my comparator, which the test data set didn't turn up. It looks good. Let's try. Woohoo! Did it.
You got both?
I got both.
And everything depends on the comparator, right?
Everything depends on getting the comparison right.
Have you removed something? One collection from another collection, or you don't play with remove? Just compare?
I just do some comparison. As usual, the code is but ugly. But comparing trees is a challenge in itself.
Are you able to show your solution for the audience?
Yes. Okay, let's get back to the riddle. So, this is a test data set that I put in myself, but it wasn't that useful. I'm kicking that out.
Yeah.
So, for part 1, I read the file as usual in line-wise, so I get a list of strings, and I iterate through them in sets of 3s. So the left the considered left packet, the considered right packet, and the divider line. And because I know that each third line is empty, I just go look through the first 2.
Mm-hmm.
Parse them, compare them, and if the result is lower than 0 or 0, as per the Java comparator interface, 0 means they are equal, -1 means this is smaller than this. So if it's negative or 0, they are in the right order. Only if they were positive, they were considered for this riddle in the wrong order. So I can take this integer value and check it on less or equal 0, and sum the indices of the pairs, which I count separately, which are in the right order.
Okay.
So, for the comparator itself, or rather, I have a class tree node, it has subnodes, and if it's a leaf, it can contain a single value. So, breaking this up, if I encounter a literal that is, I didn't mention it, I use string tokenizer.
Yeah.
And I have this little method. So this is the input string. These are the delimiters, opening and closing brackets and the comma. And I want the delimiters to be returned because they give me the structure. So starting the parsing, I throw away the very first token because I know it's an opening bracket. And I'm creating a tree node for that automatically, so I don't need it. Then I use the string tokenizer in the constructor to pass through the input. If I encounter an opening bracket, I create a new subnode. If I encounter a closing bracket, I leave this constructor instance. If I encounter a comma, I do essentially nothing.
Nothing, yes, right. And default is the number, and you take the number.
And if I encounter a number, I create a tree node that just contains this value.
Very similar to my parser.
Now for the comparison.
Yes,
this is an ugly beast.
This is a beast, yes, right.
So, first case. Both nodes are lists. Then I have to iterate through both lists. And so I have this iterator value I. And
if both equal.
As long as I is smaller than the list length of both lists, I can compare them. And if I find two subnodes that are dissimilar, I return that as a result. Otherwise, I increment. Fun fact, I forgot to put this in and had endless loop on the first test run. If this while loop terminates without triggering this return, I just do this. So if this has fewer elements than this, the result is negative, which matches the RP description of the compare method. So this is perfectly fine. If they equal, it's 0, which is also good. And if this is bigger, it's positive. And then we know, the left-hand side is bigger than the right-hand side.
But 0 should not work, because 0 should be handled in the while loop.
If they are the same size and have the same elements, it would come to this point and return 0.
Okay.
Both nodes as equal.
Good.
So, if only one of them is a list, I used a little trick here. If this one is a list, I invert the comparison, throw in a -1 and go over to this part. That saves me some code. And we come to the case that this one is a list, but the other one isn't. So we have to recurse into the other one through the first value until we find nothing. So we will terminate if we find a value, then we can compare it, and that's it. Or we find an empty list. That is possible. In that case, our value is bigger than the empty list.
Yeah.
So we return 1. And if it's just a list with at least one entry, we recurse into the subnode and go on.
Okay.
And the final thing, both nodes are values. Yeah, that's the easy one.
Yeah. Okay, nice. How long have you do for this?
But that is only part 1.
Yeah, just... Okay, yeah, this is right. It's only part 1.
There is a second part.
Yeah. Okay, let's talk about the second part.
For the second part...
what is the riddle for the second part, please?
Okay,
we
the
do
riddle
not know
for
the
the
riddle.
second part is... Here. You just take all the packets that you get You ignore the blank lines. You just take the packets and sort them.
Okay.
You have to put them into the right order. And you have to throw in some additional packets. This and this. And then you shall, when you have sorted that, you shall take the positions of these two packets where the count starts at 1 and multiply their positions.
And it's sorted by the first package, right? The first package are 1, 1, 1, 1, 1. Then you added the 2 package, then 3, 4. Then you added the 6 package. There's no package with 5. Starting with a 5.
For the example, yes.
Okay. Mm-hmm.
So what I'm doing there, I have a list of nodes. I throw in these two newcomers.
Yeah.
And keep their object instances.
Forgetting the position.
Forgetting them later on.
Mm-hmm.
And then I pass through the input again in sets of 3. And pass just the first and second of each 3 and ignore the third. Sort the stuff.
You got
That's possible because tree node is comparable.
Yeah, it's so easy.
And then I take use the lists index of method to get the index of div2 and div6.
Yeah.
Add 1 on each and multiply the result.
Yeah. The whole world starts at 1 and all others starting with 0, ne? Very
exactly.
Pretty. Okay, cool, nice. And let's take a look at the leaderboard. Are you under the first 1,000?
I don't think so. Personal stats.
3,000.
3,771 for part 1 and 3,164 for part 2.
Okay, nice. What was the biggest challenge for you this time?
Getting the comparator right.
Yeah, still my problem.
For a second I was thinking about writing unit tests for the comparator.
Okay, cool. Frank, are you there?
I'm there. My comparator still does not work.
Yeah.
Some bug in the recursion part.
Like my comparator. So much luck to you. Thank you for you, Achim. Congratulations again, and we see us tomorrow again.
Have a nice day.
Have a nice day.
You. Bye bye.